My name is Takuya Yokota from Nihon University, Japan. Today, I'd like to talk about model for predicting 3D beach changes under compound actions of waves and wind. This is my presentation outline. The introduction. In Japan, there are many coasts where a large amount of windblown sand is transported. On a coast where a beach is wide and is composed of fine and medium-sized sand, a coastal sand dune can be formed as a result of the transport of windblown sand. Considering the amount of windblown sand is significantly large, the effect of windblown sand cannot be ignored in the long-term prediction of topographic changes of a coastal landform. And behind the coast, there are many cases of damage caused by windblown sand invading the land area. To predict these phenomena, the entire process of both sand transport by waves and the redistribution of sand by wind must be included in the model. So in this study, a model for predicting 3D beach changes under compound actions of waves and wind was developed. This is applicable to widespread area between the seabed and the backshore on a coast where windblown sand prevails. Next, field observation. This shows the location of study area. The study area is Hood's New Port, and there is a breakwater of 700 meters length extends along the west side of the Hood's New Port. At the western corner between this breakwater and the reclaimed land, the west beach is formed owing to the sand deposition, together with the formation of another beach east of the breakwater. Longshore sand transport prevails along the north shore of Hood's Caspet Foreland. The west beach seems to have been formed by the sand supply by this eastward longshore sand transport. On the other hand, in this area, WSW wind predominantly blows, so the sand deposited on the east beach is assumed to be supplied directly from the west beach as windblown sand. In this area, on July 16 and September 23, 2017, field observation was carried out. This picture shows West Beach formed at corner between Port Breakwater and reclaimed land. The upper part of West Beach was covered with the coastal vegetation, and the height of the West Beach covered with vegetation was larger than the crown height of Port Breakwater, and sand was partly deposited on the crown on the Port Breakwater. From this fact, it was realized that sand was transported from the West Beach to the East Beach over the crown of the Port Breakwater by the west wind. And this shows sand deposition on slope along eastern edge of Port Breakwater. Sand covered the top of the concrete blocks placed along the western edge of the Port Breakwater, implying that the sand was transported eastward by wind over the reclaimed land and deposited on top of the concrete blocks. And next, this shows topographies of west and east beaches. The elevation of the west beach is higher than that of the east beach, and the elevation of the beach where it met the Port Breakwater was 2.5 meters, and the elevation of the east beach was 1.5 meters. In addition, the water depth of point P was 2 meters, implying that the water depth surrounding the east beach is at least 2 meters. Next, this shows the aerial photograph of west and east beaches between 2000 and 2018. Both beaches gradually developed over time, and the areas of both beaches were calculated from aerial photographs. This shows changes in foreshore area of west and east beaches. The rate of increase in the foreshore area of the west beach decreased after 2008. In contrast, on East Beach, it increased after 2008. This is because after the West Beach had significantly developed, the transport of windblown sand from the West Beach to the East Beach was accelerated. So from this result, sand supply from the West Beach to the East Beach since 2008 is 158 cubic meters per year. Next, I'll explain the predicting model. In this study, the beach changes due to waves occurring in the depth zone between the closure depth and the berm height were predicted using a model for predicting beach changes based on Bagnall's concept. On the other hand, topographic changes due to windblown sand were predicted in a zone landward of the berm top by a cellular automaton method. And this shows physical meaning of BZ model. And in the calculation of windblown sand by a cellular automaton method, the two most important processes, saltation and avalanche, were taken into account. Saltation is a process whereby sand particles are transported by wind action, and the saltation distance Ls is defined by this equation. This equation is the simplest polynomial expression that can be used to evaluate the observed result of the sand flux on the sand dune, including multiphase flow. The rate of windblown sand is assumed to attain an equilibrium state at the location distant from the starting point for the approach run in the downwind direction. The moving mass was given by the value multiplied by the coefficient mu shown in this equation. This shows calculation conditions. Calculation conditions were set based on the survey result and waves and wind observation data near this location. And next, this shows the initial topography. From the observation result, the ground height of the port breakwater and the walkway on the reclaimed land was 2.5 meters, and the west side of the port breakwater, a slit bed with a constant depth of 0.5 meters was assumed, and the wave direction was 20 degrees counterclockwise. And the east side, a slit bed with a constant depth of 2 meters was assumed, and the wave direction was 75 degrees clockwise. And wind direction was 70 degrees counterclockwise. And sand was supplied from the west end of the calculation domain at every step. And this is the calculation result. The West Beach has gradually formed since 2000, and windblown sand was transported over the port breakwater over time and deposited inside the port after 2008. At the corner of the port breakwater and the seawall, windblown sand has been deposited and the ground elevation has increased. This is in good agreement with the conditions measured in the field observation. And next, this shows a comparison of measured and calculated changes in area of West Beach. Calculation results are in good agreement with the changes observed from the aerial photographs. Furthermore, the rate of increase in the volume of the East Beach calculated since 2008 was 164.4 cubic meters per year. It was in good agreement with the value of 158 cubic meters per year estimated from the field data. Conclusion. In this study, a model for predicting 3D beach changes under compound actions of waves and wind was developed by the combination of the BG model and the cellular automaton method. To verify the effectiveness of the model, field investigation and the analysis of aerial photographs were carried out, taking beaches formed at Foots Newport. It was found that windblown sand was transported from the West Beach to the East Beach over the port breakwater, and the result of the numerical simulation were in good agreement with the measurement result. In the present model, the topographic changes caused by not only waves but also windblown sand can be predicted simultaneously. This ends my presentation. Thank you for your attention.